Alright, so last chapter we spent talking all about triangles, and we're going to continue our discussion about triangles and talking about a bunch of different segments inside of triangles. And so today we're going to talk about the midsegment. The midsegment is one that connects a midpoint to a midpoint. And so remember that the midpoint splits something up into two congruent parts. So D is the midpoint of C and A, and E is the midpoint of A and B. Then there's also a midpoint down here. And so what I want to talk about is the midsegment. And the midsegment is one that connects the two midpoints. And so in any given triangle you could have one midsegment, two midsegments, three midsegments. But in talking about this one right here, I measured this one. This one is 4.35 when I connect D to E, the two midpoints. And then this bottom part of the triangle, the side related to it, is 8.7, exactly twice as much. Now, if you measured this angle and this angle, both of these angles are equal, which tells us also that this is parallel to that. And so that will happen every single time you do a midsegment. And I put a link on our Moodle site that you can sort of explore dragging points all over the place and noticing that this is always half of this. Even if we drew this one is half of this. And so the midsegment's always half as long. And then in addition to that, like I said with the angles, because these angles are corresponding angles, by the converse of that, if the corresponding angles are congruent, then we've got parallel lines. So, the midsegment theorem, segment connecting the two midpoints, the midsegment, is always parallel and half as long. So, a couple different questions you can see. The first kind of questions you might see are just, hey, DE here, DE is this segment, is parallel to this segment right here, AC, or you could say AF or FC. Let's go over here. FE, which is this right here, this midsegment, is 5, and so that tells me that AB, this whole thing, is 10. Now, something to note here just while we're talking about it is that this AD would be 5, because it's half of it, and this would be 5 as well. AC is 24, so this whole bottom part of the triangle is 24, so we know DE is half of that, which is 12. AB is parallel to this one, FE. BC is parallel to DF. And FD, which is FD right here, is 32. And so if that's 32, then this whole thing over here has to be 64 BC. So that's strictly with numbers, and then what we do sometimes is we throw in some variables. So it might look like this. If DE is 4x plus 5, this right here, and GJ is 3x plus 25, let's find DE. Well, so this is half as long as this. And so I could say 1/2 of 3x plus 25 is 4x plus 5. So that's one way of saying it. But I like saying it this way: double the short piece, double the 4x plus 5, and then you can get the other one. So 2 times 4x plus 5 equals 3x plus 25. Distribute your 2. Subtract 3x, you get 5x. If you subtract the 10 to the other side, you get 15, and x equals 3. But don't stop there, because we want to find what DE is. So plug DE back in. So 4 times 3 plus 5 is 17. And if you plug it back into GJ, you should get exactly twice that, 34. And you do. So for the second one, it's very similar, except it gives you EF is 2x plus 7. And GH, this whole thing right here, is 5x minus 1. So if you double the short piece, you should get the long piece. Double the EF, so double 2x plus 7 equals 5x minus 1. So distribute, subtract your 4x, you get x, and add your 1, you get 15. So if you plug in 15, I plugged 15 into GH, so 5 times 15 minus 1 is 74, but I wanted to know DH, which is going to be half as long, so it's going to be 37. And then finally, we have HJ is 8x minus 2, df is 2x plus 11, so you can say 2 times the short one equals the big one. Solve that out, distribute, subtract, combine your like terms, all that, you get x equals 6. Plug 6 back in, 48 minus 2 is 46, and so HJ is equal to 46. And that is the midsegment theorem.